So we want to find the Cartesian equation, and we know what that means. It means we want to eliminate the parameter. We have this in terms of t. We want to get rid of these variables here, right? How do we eliminate them?
Don't worry about it.
Well, we've got this guy over here. Yes, what can we substitute? Yep.
I always get confused with like the in terms of thing, but not t as the subject.
Yeah, right, because you want to get rid of that. So if you write t in terms of x, you can substitute that in and get rid of it, yeah? Also kind of look out for little tricks here and there because this might be confusing as well. That's just x, okay? So you can rearrange these, right? What you might notice is this guy over here kind of looks similar to this, right? What can you put in? So like one trick you might want to do is if you factorize out this 400 over here, yeah, so you get, what's this, 1 minus e to the negative t on 5, which actually looks kind of familiar, right? What does that look like? It actually just looks like this guy.
It's going to be plus 400.
What?
We factorize plus 400.
Oh. Yes, good point, thank you. So that's x on 7, that's just x on 75, right? Can you see that? So that's like a little trick to save you a bit of time, rather than substituting like what t is into this. We are going to find what t is, ultimately, but that's just something to look out for, potentially, right? Did you get t as the subject for this one as well? How can we get t as the subject for this guy? Sorry, this is going all over the place with the working, huh? We also have this guy here, right? Yeah?
There.
Where?
Like way back when I was walking out. We showing that t as the subject.
Oh, did we? What was it? For x?
Yeah.
What was it?
T equals -5 sine x plus equal to x.
-5 sine x. What?
That's my velocity.
Yeah, no, that's for velocity. You can't use that one, right?
Anyway, so
Yeah. What did you get then? When did we use find t? I don't remember doing that. You said we found t earlier.
Yeah, we had t as the subject.
For velocity.
Yeah.
Okay. So you still have to rearrange this one, right? So I'll just do it up here. X on 75. Let's take away 1 from both sides. And then, oh, okay. This is not the super nicest equation. We can get rid of these negatives here, multiply everything by -1. And then again, use our log tricks, right? So we've got take the log of both sides. And so this is t is going to equal to, multiply both sides by -5. Now, one thing they do in the textbook is they don't leave it like this. They actually put it under a common denominator.
Also 75 minus x.
Yeah, and then they also get rid of this negative, because if you think about negatives, right, what do negatives do? Yeah, if they can be treated as powers. So coefficients can be treated as powers here. So they actually also get rid of the negative. That's just something that they do there. That's not completely necessary, but I'll write it anyway. Their final answer is t is equal to, so we'll do it step by step. So it's -5 ln, this whole thing becomes 75 minus x on 75. But then they take this power, the -1, and they put it up here, which takes the reciprocal of the inside of the log. Again, this is not necessary, but I'm just showing you what they do, just in case that comes in handy. And so you actually have an expression for t as well. The 5 should be written there. And so you can see that rather than substituting that into t here before, that actually saves us a lot of time, right? Because we can actually just write that as x on 75, which is a lot nicer, right? So we still have the t value that we're going to substitute in. So it's -50 outside of 5, so what t was over here, 5 ln 75 on 75 minus x plus 400. Now I'm not going to have to substitute t into here. All I can do is I can just write x on 75 here as well, right? So that whole thing is x on 75, which is quite nice. And so we're going to get, what's that, -250 Does 475 simplify at all? I don't think so. I don't think that simplifies at all. 475. So negative 250 ln 75 and 75 minus 8. Can you check for me? Maybe not. Yeah.
No, it's not.
I don't think so.
Cool. And that's projectile motion with resistance. That was one question.